Everyone, today let's go over another medium question that I just solved by myself. After a long time of struggling and not being able to get over time limit exceeded and giving a brute force solution, I finally figured it out by myself. So really proud of that, and let's go over it. So basically they give you a zero indexed array and you want to find the minimum sum where, first of all, you want to find triplets where basically you have three triplets. Let's call this first, second, and third. The triplets have to be like this in terms of value. And also, in terms of index, this has to be true. So we just want to find the triplet that has the minimum value and that satisfies this condition, right? Any triplet. So I'll show you the way I was doing this before, which is just a brute force way. Do a triple loop. Right, for j in range I plus 1 length of nums, because j has to be bigger than I, right? J is second. Same with third. Range j plus 1 length of nums. K has to be bigger than second in terms of index, right? That's why we start k at j plus 1 to the end of the array, right? And then I would just say if nums of I is less than nums of j, and so basically the middle one is the biggest one. If that's the case, then we declare a result goes to minimum of results and nums of I plus nums of j plus nums of k, right? So we want to find the minimum. And then at the end, if result hasn't changed from the beginning when we declared it, so there was no sum at all that satisfied this condition right here, then we just return -1. Otherwise, we return the result. Okay, so while this is my old approach, it technically works. Obviously, it's not fast enough. So let's think about a better way to do this. So, as you can see, you're almost there, but you're not quite there. So because you know that I is less than j is less than k, how about we think about this for a second? You can't ever have a triplet where, you know, the middle is the first or the last element because of this condition right here. So how about we start here and go here? So if you know how a sorted list works in Python, then this actually becomes really easy. Let's call this lefts and rights. So if you make some observations, what we want to do is we want to get it to start at the triplet where the current element j is 6, and then the left sum is 8, and then the right sum is 1, 3, 5, and then keep going. So 8 and 6, and then 1, and then 3 and 5. So this needs to be sorted because we want to find the minimum triplet, right? That is valid, right? The minimum. Okay, that's a possible answer. It's not necessarily the answer, and we're just going to keep going like this. And then 5, and then the right is 3. Sorry, this is supposed to be in sorted order. 1, 6, 8. So that's why you see the 9 here, because you get 5 plus 3 plus 1. So we always want to select the smallest element out of both lists if possible, because that's going to give us the minimum overall sum. And now let's iterate from left to right over our array. And we can say, so the right starts like this, except in sorted order. So right is going to be 1, 3, 5, 6, 8, 1, 3, 5, 6, 8. So rights.remove nums of I. And then let's call this current. Let's print lefts and rights. But we also have to add nums of I because that's going to happen after, because we don't want to include the current element that we just removed in our window because we're starting from the second, right? So we just want to make this picture, and now we can, this is almost what we want, but we also, just to make it easier, let's print what the current element is. This is going to be the middle guy, like this. It's easier to visualize. And we don't care about this list because we need something on both sides at all times. So this is everything that can possibly be an answer, right? Okay, and also this doesn't count. So let's say if I is bigger than or equal to 1 and I is less than length of nums minus 1, then we can do this. Oops, sorry. So if I is bigger than or equal to 1, then that's when we print this, right? Just so you can see. And then this also has to be valid. So and I is less than length of nums minus 1. So we're only including these, right? Cool. So now we have some possibilities, and what we want to do now is find the smallest triplet, right? So we have our current element, then we have everything to the right side and everything to the left side. And how do we minimize the triplet? So we are just going to say, first of all, we got to make sure this guy is actually within bounds, because this also has to be bigger than the biggest in the left list because of what this says right here. So if lefts and rights, first of all, we need both lists. And if left of 0, which is going to be the smallest one because this is going to be in sorted order, is less than current is less than right -1. Now let's just print this to make it more clear. Now we actually have a possible result. Rights. Okay, so current is... Okay, so it's supposed to be bigger than rights 0 because of what we said above here, not less than, but everything is smaller than the middle value, what we're doing here. Okay, cool. So now we have a possible solution, and the smallest is always, as I said, is going to be the leftmost element of each list plus the current element, because the current element always has to be included, right? And then at the end, we can just do the same thing, declare result as float of infinity, and then find the smallest possible sum, which is left 0, right? Left 0 plus current plus right 0. It's going to make it as small as possible. For example, here, we know we have to include current, so the smallest sum is going to be the 2 lefts because of the sorted list. And then at the end, same here, if result hasn't changed from the beginning, return -1, else return the result. And we might have to get rid of this print statement, but I think that should work. Okay, let's get rid of this print statement. And there you go, passes all test cases. It's not the most efficient. I think you can make this a little more efficient if you say cursum is equal to left 0 plus current plus right 0. And then if cursum is less than or equal to result, result equals to cursum. Because apparently this is O of n actually in Python, so let's try it again. Okay, I guess not. So yeah, I'm pretty sure you could optimize this even more, but this is my own solution, and hopefully it's pretty intuitive the way I explained it. And if you enjoyed this video, please subscribe and please stay tuned for more content.